Hello, everybody. Thank you for joining us today for our last workflow series here with ClearEdge 3D. Today, we are going to be looking at Rithm for Navisworks and talking about floor flatness. So, yeah, let's move on to some housekeeping stuff. First off, everybody is muted, except, of course, for me and Zoltan. But you can ask questions throughout the presentation using the chat in GoToWebinar. So please feel free to ask questions whenever they pop into your head, and then at the end we will take some time to do the Q&A, basically work through those questions. We are recording the webinar, and it will be sent out to everybody who's registered for the webinar basically in about a week or so, once we've had time to do any kind of editing and tweaking we need to do. But yeah, that will happen within about a week. And you know, if there's anybody else that you think wants to see it, you can always send them to the registration link, and they can sign up even after the webinar is done, and we'll get that video over to them as well. So yeah, with that, let's do some quick introductions today. So I will be today. This is Kelly Cohn, and I'm VP of Industry Strategy here at ClearEdge. My background is in architecture originally, and then I kind of moved into practice technology, doing BIM VDC management at the Beck Group. Joined ClearEdge, gosh, about 4 years ago. Man, time flies. And Zoltan very cleverly has added that I play guitar poorly. So now I know what Zoltan thinks about my guitar playing skills. But apparently, Zoltan, you like how I dance better. I don't ever recall us dancing, but thank you for that. With that, Zoltan, why don't you introduce yourself so everybody can hear your lovely voice.
With the microphone, Kelly?
Yeah.
Okay, sorry about that. Yeah, I'm having a little trouble with the microphone. Hopefully we won't get any feedback. Yeah, my name is Zoltan Frenzy. I'm the industry strategist here working under Kelly. And I've had a wealth of CAD experience working in construction and for architectural firms, doing training on architectural software at Autodesk training centers. And I've also actually gotten dirty and done the laser scanning out in the field. So I'm a bit of both worlds. And even though it scares Kelly to death, I'm avid into rock climbing and mountain biking, as a lot of us here at ClearEdge are. So let's talk about Rithm. Essentially, Rithm is a plugin for Autodesk Navisworks that allows general contractors to do some analysis and reporting surrounding floor flatness and levelness. And you can do things like create heat maps of floors and walls, or contour maps, elevation points. You can also analyze deformations before and after the concrete floor to see like what's changed and how things moved. And more importantly, you can do this all with laser scan data. So that means you can do it when the concrete's still wet. Whereas typically, if you pour a concrete slab and you want to see how level it is, you have to wait till it dries and then go and take some contact measurements on the floor. And by that time, the concrete is no longer workable. So if you find high spots or low spots, then you have to do a lot of expensive refinishing by grinding down the high spots or filling in the low spots. But with laser scanner, you can do this type of analysis while the concrete is still wet and workable, so that after the concrete is poured and screeded, you can laser scan it, do the analysis, and when you find high spots and low spots, you can instruct the crews to refinish the areas on the wet concrete, scan and analyze it again, and continue to do this until it all falls within tolerance. So at the end of the day, you'll have a perfectly flat floor without any rework. More importantly, the software allows us to do ASTM E1155 floor flatness analysis and reporting. This is an industry standard way of defining that a floor meets a certain flatness and levelness specification. Typically, this is done by an outsourced company. You have to call them up, it takes them a couple of days to come out, then they spend all day walking around on your slab with this little stick measuring thing. Then they go away and generate some reports, and another day later they email you the reports, and it's quite expensive and time consuming. But when you can bring this process internally into your organization and have it take only minutes instead of hours or days, you not only own the process, but it ends up being cheaper and faster. So let's go ahead and dive into how this looks and works. So here we are inside of Autodesk Navisworks. This is a fairly industry standard tool for general contractors that are doing construction coordination or virtual design and construction. Rithm is a plugin that runs inside of Navisworks, and so it's already kind of in a tool that's familiar to a lot of general contractors. Here I have two scans of a simple floor, and really we're just looking at the floor of the building. If I turn the rest of the points on, I've got a section box where I've chopped off just the bottom of this room. So even though we've scanned the whole room, we don't really need all this information to do just the floor flatness analysis. Instead, what we'll do is we'll just take a section box, chop off the data at about the floor level so that we only have to worry about what we want to analyze. So when we install Rithm, which is one of the plugins that also comes with our Verity software, we have this button that allows us to analyze this floor in the Rithm software. Now, one of the nice things about having this work inside of Navisworks is not only that it's a tool that most general contractors already have and are already familiar with, but it also means that we can do this analysis with any point cloud data that we can get into Navisworks. And that is typically using the recap format, which is the Autodesk workflow. So we're not restricted to any particular format or vendor for the scanner from which this information comes or the file format that you get it in. You can get these scans from your laser scanning service provider and work with it in the software that you're familiar with. All right, after a couple of minutes of processing, it's going to show up here in just a second. Hopefully. So the Rithm console is kind of a separate application from Navisworks, but it connects the two together. So you have kind of a way of working that's kind of connected to the Navisworks environment. Inside of here, we've got two toolbars for giving us some tools to work on either floor analysis or things like floor flatness reporting, ADA compliance, and so forth. If I look here under surfaces, this is where I can do things like analyze the flatness of floors, generate heat maps, contour maps, calculate cut fill volumes. I'm going to start here by doing a debris filter. And what this does is it's going to get rid of all of the stuff on the floor that's not just flat floor. So if you've just scanned your floor and it was been a while since it's been poured, typically it starts to accumulate with junk, equipment, dust piles, whatever. So the debris filter analyzes the floor surface and removes everything that's not dirt, or that's not floor, sorry. And here you can specify if we want to subsample the point cloud, maybe make it less dense so analysis runs a little faster. We can specify that we're only interested in points that are a certain elevation above or below what we know to be the floor. And mostly we just dial in some parameters here for how we want to remove this noise. And then it analyzes the point cloud and generates a kind of marks the points that are debris in red. So here we can see that some of the little bits and pieces are going to get removed. And from here, I'm going to go ahead and add a analysis surface, and I can choose a contour map or a heat map. We'll do both here in a moment. So let's do a heat map. A heat map is a way to visualize the elevation of a floor using kind of color information. There's two ways that we can do this. We can either do a high-low analysis where we assign each elevation of the floor a different color based on a coloring interval. So every 100th of a foot up to 10 intervals will specify what a unique color for each elevation. Or we can do it by cut fill, where we specify a tolerance above or below the median, which is the intended elevation of the floor, and everything above that tolerance is shown in one color and everything below is shown in another color. So we can report this either in absolute elevations or in relative elevations, and we can even specify a base elevation. If this is not checked, it's just going to take the average between the highest and lowest points. So let's kick this off. And there you can see that's the colors spectrum for the high and low. The zero elevation, which is right in the middle, is shown here in green. And then as we go up to about 1/10 of a foot, that's high areas are indicated in red and low areas are indicated in blue. As you can see, this is not a very level floor at all. There's a nice lump here, and then it kind of slopes down, sags this direction. So immediately we're starting to get feedback on what the high and low areas are. And if we were doing a wet concrete workflow, this is the type of analysis that we want to see, because when we can quickly identify where the high spots and low spots are, and then direct the people screeding the floor to redo these areas. Now, beyond this, we can communicate this information out. Not only can we capture an image of this, but we can export the heat map points as an XYZ file, which we can then run it through Recap, create an RCP project that we can then use in all of our Autodesk applications, or in this case, let's just bring it into Navisworks. And let's append it back to our coordination model. So I've already run the XYZ file through Recap, and we can link it back into the design model or the coordination model. It's all in the same coordinate space. So then we can use this information inside of Navisworks to help us coordinate things that are impacted by this floor flatness, or publish it out to anybody else who's interested in it. All right, back in Rithm here. I am going to edit this heat map that I just created. Each of these analyses have the ability to go back and change the settings for them. So if you want to, if you didn't like the results, you want to change the color interval or whatever, I'm going to change this to a cut fill mode. Same stuff. Maybe I'll set this to absolute elevation. We'll see what that looks like. In the cut fill mode, we specify a cut fill tolerance, like I said, and everything within that tolerance is shown in green. So that's the good floor. And everything that's above is shown in red, and everything that's below is shown in blue. So kind of the same color scheme that we had before, but instead we're just getting an absolute, this is the bad areas, these are the good areas. I'm going to turn this off for now. Let's look at some of the other things that we can do. So heat maps are really good for quickly communicating the information about the floor's elevations. And they're nice visual representations, but they don't make good design data if you want to have people who want to use this in their CAD software. So contour maps are similar to heat maps in that they specify the elevations of the floor, But instead of doing it by colorizing every point, it creates what is more like a surveyor's topographic map of the floor. We have the same options to do cut fill coloring or high-low coloring, and then we can specify the intervals. And when we generate this information, instead of colorizing each point on the floor, we get CAD lines for each of the elevation intervals. So this is CAD geometry that designers can use and can be brought into other applications. You can take this into Civil 3D, for example, compare it to the proposed grading. If this wasn't a floor, let's say we're grading the site before we pour the concrete slab, or we can bring this into Revit and make a topo surface out of it so that we can start to build an as-built model of the actual floor. So here under export, I can export this out as a DXF format. And just like I did before, back here in Navisworks, I'm going to append that DXF. And we can bring it into our coordination model just like we did before and use it for communication and coordination purposes.
And if this one of the nice things I think about doing floor flatness analysis this way, you know, if you're doing your laser scans on control and you get it in your model coordinates, right, is that, you know, all this information then can come in, you know, in context of your model, whether that's at Navisworks or Revit or somewhere else. So it's not like you're getting a, you know, isolated floor flatness analysis, you know, that's you know, dropped onto a 2D drawing or something, and you've got to, you know, try and figure out how to get that back somewhere in the field. You're actually, you know, able to look at this in context of your model, you know, in context of your drawings, and everything is located precisely. So it's nice to be able to pull these things across, you know, maintain coordinate systems. So
absolutely. And what's more interesting is we can load this stuff into a total station. And if we have like a robotic total station, we can lay these points out back onto the floor. One really great way of doing that, instead of loading all the contours, which you can do, but instead we can take single point elevations. I'm going to create a new layer here and call it points. And let's make this layer white. It's nice to organize things in layers, keeps things nice and separated. I'm going to add some additional elevation points where I can specify an identifier number and an optional descriptor. I can show the point numbers, the descriptions, and also the easting, northing, and elevations of these points. So this is nice for locating, let's say this is a high spot in the floor. I'll pick it there, I'll call this the high point. And then I'll pick maybe a point over here. I'll call this the low point. And then, of course, once we have these points, we can then export them as CSV files. And typically, most total stations will be able to take these files, and we can do all sorts of fun things with them. I'm going to turn off the visibility of the contour map for now. And let's take a whole grid of these points. We can take individual points, or we can take a collection of points if we want to shoot out a grid of checkpoints on our site, for example. Same thing, we can give it a descriptor and a starting number. I'll specify the spacing between the intervals, and then let's just not do any coloring for now. So here, I'll pick a point on the floor. That's the first point. And then the second point defines the direction of the columns. A third point defines the direction of the rows. And here now I have a nice grid of elevation points at regularly spaced intervals that I can then send out to an Excel spreadsheet or any other standard output that can take a CSV file, like a total station, for example. So what's fun about all this is there's a couple of ways that we can look at this. Right now, they're all just white points, but if I change the visibility, I can color them by elevation. And now these points have the same coloring that the heat map points or the contour map points have. where our high areas are in red and our low areas are in green. And if I set a reference elevation, let's say I'll set my reference to 99.99 feet, I can change this visibility to color by reference. And now everything that's within tolerance of the reference elevation is shown in green, and everything that's high and low is shown in the cut fill colors. So this is the same kind of analysis that we were doing with the cut fill coloring, but we're doing it on individual elevation points. And beyond just exporting this as a CSV file, we can generate some reports either in the Word or PDF format. And let's just run this out. I'll just replace this one that's here. And let's create a report. So these PDF reports are nice because we can then use them to communicate information to those non-CAD people, the ones that aren't using the fancy software like Navisworks, and we just want to give somebody something in an email or something to look at. All right, there's our report. So it shows a screenshot of the captured points, a nice table of all of the elevations, and so forth. So great for communication.
And as somebody who's had to walk out on a floor slab and take a grid of points with a total station, you know, on a 5-foot interval or on a 10-foot interval, you know, I remember the first time I saw this and was like, oh my God, it would have saved me so much time, so much pain on so many jobs. So it's one, I know it's not as cool looking as the heat map or as the contours, but like to me, that's like one of the most exciting features because I've had to do it the hard way.
Yeah, absolutely. So surveyors love this stuff because it's like a virtual total station on your desk. You don't have to go out to the site if you want to make spot checks of certain things. So going back to reports, one of the most important reports that we can generate for a floor is the ASTM E1155 report. It is a standard report that defines that a floor is within a certain specification for flatness and levelness, and it is an ASTM standard. So it's accepted by the industry as being the way to document the flatness of a floor. First, I specify an area that I want to analyze, and then it gives me a little guidance about how this analysis should take place. If you're familiar with 1155 reporting, typically what you have to do is you take some test lines that are a number of vertical lines and a number of horizontal lines, and how long these lines have to be depends on some criteria based on the size of the
Oh man, did we just lose Zoltan?
area. And there's other criteria that my horizontal lines and my vertical lines have to be about the same length. Oh, did you? Am I back now?
We got you back. There was a strange pause.
Can you see my screen or hear me?
Yep, we're all good. Yay, technology.
Yeah, that's what happens with the internet. Right. So going back a little bit, the ASTM standard specifies that within a certain area, there has to be a certain number or length of analysis lines. And so this dialog box gives us some information that specifies that when the total length is above the minimum and the total length of horizontal lines and the total length of vertical lines are the same, then it flags us with these little check boxes to let us know that everything is good according to how this test is supposed to be taken. When we're done creating these lines, we'll do the actual analysis, and what the software does is along the lines, it samples the floor at 12-inch intervals and then does like a statistical analysis of the points in that area to find the accurate elevation at that point. And then it does the industry standard calculation for what is the definition of flatness and levelness between those points. And it gives us the FF and FL numbers for the analysis runs. It also shows us a little diagram, kind of an exaggerated contour along that line. When all this analysis looks good, the meat of all of this, of course, is to create the ASTM E1155 report, which is in the standard format, and it is in the exact same way that your outsourced service provider will give it to you. It looks how we expect it to look, where we get the nice screenshot, but we get all the pertinent information for the pass-fail numbers, for what is the FF flatness requirement, FL floor levelness requirement, and then it breaks down all the grids, or the graphs, I should say, for each of the analysis lines. So here in the last 5 minutes or so, we just did what an outsourced contractor would spend all day walking around with a dipstick and then going off into their office and running it through their software and emailing you back into this report. But we've all done it in-house for free and in little time at all. So that's just kind of some of the stuff that Rithm can do for floor flatness. I haven't even gone into monitor changes, where these grids of points and elevation points, if we lay them down on a, let's say, a concrete slab before we load it up with a bunch of heavy equipment, or before the concrete cures, we can analyze those same points after the concrete cures or after some loading condition, and look at the changes in elevation at each point to see how much the floor has deflected. We can also do this with a beam camber analysis. So if you're pouring an elevated concrete deck that's held up by steel joists, you can scan the deck from the underside and measure the beam camber on each of the steel beams. And then using the monitor changes, we can look at the change in camber pre and post pour. We also didn't get into the volume calculations. This is cut and fill volume. When we did the heat map, we saw the areas that were too high and the areas that are too low. The cut and fill volumes will give you the actual calculations of what those are. So if you're so unfortunate to have to grind off material or fill back material, let's say it's an existing floor and you didn't get the luxury of being able to pour it, then you can determine how much of that remediation process you'll need to do. And we can also do wall heat maps, which is kind of the same as the elevation heat maps, but on walls. So if you cast in place a concrete retaining wall and you want to see if it's like bulging out because your formwork has gotten a little funny, you can do an analysis on that wall to see if there's any issues there.
And don't forget my favorite thing that I named my daughter after, our ADA function, Sultan.
Ah, yes, Kelly's daughter is the Americans with Disabilities Act. This allows you to do some ADA compliance analysis, where we can do single slopes or grids of slopes, which is kind of like grids of points, but it'll let you know which way and how much each of the points is going. This is also good for slope to drain slabs, but it also gives us ramps analysis, which is ADA compliance has some specifications for how handicap accessibility ramps need to have minimum slopes in the transverse direction, or maximum slopes in the transverse direction, and slopes and lengths along their line. And so if you ever have to do ADA compliance, these are some tools here. And of course, we can generate wonderful reports for all of this.
Yeah. And there's some of these things that we'd love to show you, but we wanted to stay focused kind of on the core floor flatness functionality for today. Also, if we've got any current customers on, people that have used Rithm in the past, you may notice a different version number. Zoltan's actually showing our next version, which is 1.9, which will be out in about a month-ish. Super secret, but you'll have noticed some of the guidance features in the FFFL analysis that are not in the current version. The cut fill stuff is now publicly available as opposed to a hidden beta. And probably the biggest news, it's 4 times faster. So we've basically substantially sped up getting the laser scan points from Navisworks and Recap into Rithm. So it's much faster in terms of working with those data sets. So I did want to give a quick shout out since we are showing the new version there. But yeah, and so for instance, 1 or 2 of those things are still being worked on by the developers, and they will kill us if we tried to show them to you right now because they might break.
Yes, the fun risk of demoing beta software.
Yeah. Hey, it works just fine. So with that, let's pop into some of the questions here. So first one that came in was, when would you use the subsample? I see you have that, not enabled. I think this is when you were running the debris filter. That's all done.
Yes, when would you use the subsampling? That subsampling is actually in a couple of different places in the software. One is in the debris filter, which is kind of like a global subsampling where you can take your entire data set after you've removed all the debris, and you can kind of decimate it down to an even grid so you'll have less points. This causes the software to run faster because there's less points that it has to analyze. And for most of these operations, like contour maps and cut fill volumes, the software doesn't need a whole lot of point density to do the calculations well. And so it's mostly a performance factor to be able to speed up the software, especially if you're working with a larger slab area. The other place you can do the subsampling is in the heat map dialog. If you just want to subsample one area for the heat map differently than the rest, you can do that just for the heat map results. But yeah, excellent question.
All right, and then can you export the heat map as a DXF or a DWG? Which I don't believe you can.
Yeah, I'm not sure if you want to, because heat maps are very many points. Point clouds typically contain tens of thousands or more points, and you wouldn't want to fill up your AutoCAD drawing like that. But since the heat map is exported in an XYZ format, which is kind of like the CSV version of point cloud data, it's basically a text file that's comma separated values, except your columns are X, Y, Z, RGB for color data. And if you massage that a little bit, you could probably bring it into your CAD software by importing that as a CSV file, and you'll essentially get the same results. Yeah, interesting question. I've not heard of anybody that wants a DXF of the heat map, but I guess you could do it.
Yeah, if you do the CSV, that makes a lot of sense. All right. And here's a good one. If you have to do multiple areas, different elevated slabs or obstructed areas forcing multiple areas, how can you get the contour lines to continue the color scheme? And he gave an example, but one of the ways you can do that is by setting it to a reference elevation, right? And Zoltan, I think you had showed that briefly, but you want to elaborate on that a little bit?
Yeah, absolutely. So in the contour maps and the heat maps, the coloring is based on how much it's above or below a reference elevation. And if you don't specify an explicit reference elevation, it takes kind of the middle elevation between the highest and lowest points that it finds. But if you know that on one part of the slab, the finished floor elevation is supposed to be at a certain fixed elevation, you can set that as an absolute reference elevation, and then your coloring will go above and below that. So if you do the same on 2 different elevations, you should get the same coloring in terms of where they are relative to that reference.
Yeah, indeed. And we got this question, I think, from both Jason. Yeah, I think he asked it two different ways, actually. So can you set ranges of acceptable elevations for the point elevation report slash for the contours as opposed to just one? And I actually think that's how it behaves. There's both a reference elevation and a tolerance, and that tolerance is what gives you that range plus or minus that reference elevation. Is that for the points as well as the contours, Zoltan?
Yes. So when you're doing, let's say, a heat map and you've got the cut fill coloring, what's shown in green is everything that's plus or minus a tolerance of the reference elevation, and you specify that tolerance amount. So when you do the grid of points, when you color it by reference, the ones that are green are the ones that are within that tolerance of the reference elevation that you set.
Yeah, so if you're, not wanting to freak out your client, since that was in the second question, you need to set that tolerance value to what you think is appropriate for the kind of work that you're doing. We've got a question about, can we generate a non-regular grid size, like for instance, 5 feet by 10 feet?
Not currently. Yeah, so we specify a grid interval, and that's what's used for the rows and columns, but I believe that's something that we've got on our feature request list, because it does make a lot of sense to sample horizontal points differently than vertical points. But yeah, good suggestion.
Yeah, and I depending on what you're taking that report out to, you can certainly do some hacking where you, sort by row or sort by column and, delete half of them, in something like Excel or something else downstream. But yeah, I like that. Just give an X and a Y direction. So, let's see. Andy Huntley asked, what scanners can I use? Hi, Andy. I haven't talked to you in a while. So what scanners can I use? Well, Rithm will work with any scanner that, collects scan data and, can, any terrestrial scanner, I should say. Well, actually, it will technically work with mobile scan data too. It's just mobile scan data is inherently much less accurate than terrestrial scan data. So I don't think it's a very wise choice for a floor flatness analysis. But basically any terrestrial scanner on the market, because they can all export to at least one format that Recap can index. And once you have the points into Recap, you can basically use them in Navisworks and therefore in Rithm. There are, certainly some scanners, that I think are, really nice to use with it. Obviously the more accurate the scanner, the better its returns on, a wet surface, the better. So, there's some really great high accuracy scanners out there. Our parent company, Topcon, has a scanner that's basically kind of custom designed for this purpose in terms of it's designed for flat work and was actually originally designed to scan asphalt, which is black and kind of shiny. And so, it's got some interesting settings on it for patterns and just a really great instrument for scanning floors, and the instrument can scan prisms. So you can get all of your scans on control right off the bat. So there's some pretty cool stuff there. That's the GLS 2000, but happy to talk to anybody offline about, scanners, optimal scanners to use with the software. All right. What is the optimal distance range for FFFL? Zoltan, you want to take a stab at that?
Oh yeah, that's a pretty loaded question, because there's a lot of factors on what's going to give you good scan data on floors. And as Kelly was saying, different scanners have different results, because scanning floors is particularly tricky, mostly because the angle that the laser makes with the surface starts to get really shallow as you get farther away from the scanner. This is typically because these scanners are only mounted on tripods that are 5 or 6 feet up off the ground. the scanner that Kelly mentioned, the Topcon GLS 2000, it does something really smart about the way that it changes the scan pattern so that it gets even distribution of points that are very far from the scanner. And it also has a high power mode, which can increase the laser power to get more return on shiny surfaces. And also when you get very low angle of incidence, most of the laser energy gets bounced away instead of back to the scanner. So optimal distance for how far you're going to get good scan data from the scanner has really to do with the kind of scanner you have, how high it is up off the floor, how shiny the surface is, because wet concrete is going to reflect more laser light than dry concrete just due to the nature of its shininess. How dark the surface is, asphalt is going to reflect less laser energy than gray concrete. Sometimes there's people that use a black concrete, or if you're doing a floor that's been painted with an epoxy or something. So the range from the scanner really depends. And in my experience, I've typically seen that most of your standard terrestrial laser scanners like Ferrofocus or Leica RTC, they're going to get good scan data 50 to 60 feet from the laser scanner. Or am I thinking meters, Kelly? We did this test. I always get these confused.
No, it was feet, I think, just because of the
Yeah,
density.
yeah, it was about 20 meters, I think. So typically, yeah, 20 meters, 50 to 60 feet from the scanner. That's when the scan data starts getting really stripy on typical laser scanners. The GLS 2000 in the floor flatness mode that I've talked about, it changes that pattern so you don't have those stripes, but you can get good scan data almost 80 meters, which is almost 200 feet from the scanner, but they're gonna be spread out, right? So it all depends. That's a very good question.
Yeah, and it depends on what kind of analysis you're going to run. If you're trying to do heat maps or contours, you can have much less dense data. So, having a point, every couple of inches, even up to every foot, that's going to be okay if you're trying to generate, rough contours or do a low res heat map. I think if you're trying to, certainly if you're trying to do an FFFL analysis, if you're trying to do any kind of more precise measurements, you need a lot more density. And so, yeah, I wish there was a simple answer to this, but the truth is, it's just there's so many factors that can influence it. So I think it's one of those things that we spend a fair amount of our time kind of training. When customers buy our software and they're trying to get out in the field and do this, we try and spend a lot of time helping them understand those variables so that they know where to set up their scanner, how to set up their scanner to get the best results. And so, we had a conversation with somebody a couple of weeks ago that was trying to do the beam deflection stuff, and they were setting their scanner up on a 6 feet up on a tripod. The beams were 12 feet, bottom of beam was 12 feet above finished floor, and they were having a hard time because they were doing just a couple of scans in a long bay, and they weren't getting much density on the bottom of the beams far away from the scanner. And it was like, well, gosh, why are you setting it up on a 6 foot tripod? You're trying to get the bottom of beams. Put the scanner on the ground. That'll give you a much better angle of incidence to the bottom of beams. You'll have to do less setup. So there's lots of stuff like that we can kind of walk people through. Cost of ownership. Zoltan, you know that off the top of your head?
That's not my job.
So last I checked, this is terrible because like neither Zoltan nor I are on the sales side of the org. We ought to just know this, but last I checked, Rithm was I think $199 a month, and
that sounds right.
Yeah, that's an annual subscription. So it's $199 a month annual subscription, so about $23.90 or something if I've done my math right. So just under 2,400 bucks a year on an annual subscription.
Yeah, I've done a lot of software demos, and when anybody asks me how much does it cost, I always just point to the sales guy in the room, like, talk to him. I'm the technical guy.
Right. Oh, hey,
Unfortunately, you got two technical guys in the room right now.
this is my favorite question. This is my favorite question I've ever gotten on a webinar. I'm sold. How much? So we just answered his question too. All right. Thank you for that, Carlos. John Zahn asked, does that mean you would have to do each scan separately? And so the answer to that, John, is no. We recommend that you register. If you're doing multiple scans, we recommend that you register them together. That's generally part of the typical process, and that you bring all those scans in. So what you saw on Zoltan's screen is actually, I think, 2 or 3 scan positions all registered together. So we were looking at 2 or 3 scans and analyzing them all together. Let's see, and when utilizing absolute elevation for reference, I think I maybe understand the question better. There was a ... Do you have to do each scan separately when utilizing absolute elevation for reference? And the answer is no. So same thing, as long as the scans are registered together, then all of those tools work across multiple scans. Can you set a separate up tolerance from a down tolerance? And Zoltan, I believe that is going to be a no, not currently.
Yeah, the trick there is to move your reference elevation to halfway between what your upper and lower tolerance would be. But that is a nice feature, I think, because you typically know what the reference elevation is, as in that's the design finished floor elevation. So having that control is probably a nice feature request.
Yeah, I'm actually jotting that down as something to talk to the dev team about. I like that.
Yeah, so that's what us industry strategy guys do. We talk to our customers about their needs and requirements, and then we communicate them back to the product management and development team.
Yeah, absolutely. Awesome. All right. Let's see. All right. Fantastic. I think we've answered pretty much most. Oh, here's one last question. How long does it take to get results from the time of scan to reporting back to the field in the concrete pour scenario? And how do you relay the information if you are processing in a separate location from the scan site? Yeah, a great question. So, it really depends on how big the slab is, and therefore how many scans you're going to have to do. So, on a typical slab, if you can set up the scanner where it can see and scan the whole slab in a single scan, and you can set that scanner up on a control point so that you know where it is, you can turn this information around on site really, really quickly. So, doing a scan will take 5 to 10 minutes, and at that point, if it's already on control, you don't have to do any registration or anything else. You're basically indexing it into Recap and then loading it into Rithm, and basically at that point, you saw how quickly Zoltan could crank out various different types of analysis and generate PDF reports or spit out points that you can send to a total station. So, we've definitely seen people in the field from single scan setups turn things around in 20 minutes. So, we're talking about working for wet concrete. I mean, you've got to be in that 15 to 20 minute or less window, because concrete doesn't stay workable forever.
Absolutely, yeah. I've actually done this workflow with a laptop out next to a job site at 5 in the morning when they're pouring concrete, and you typically want to have the computer there next to the laser scanner, because it doesn't make a lot of sense to be kind of off the site, since you'll be doing the scanning, analyzing, telling the people where to refinish the high spots and low spots, scanning again, analyzing, and then repeating that process as many times as you need while the concrete is still workable, until the floor comes within tolerance of your elevations. And as Kelly was saying, these scanners, like if you're scanning with a Faro focus, you don't have to do the color capture. You can probably do it on a fifth or a quarter resolution, so your scans will be 5 to 8 minutes per scan. And then to relay the information back, if you are scanning on control, then the northings and easting of the points that you stick down on those little single points that I did, you can then relate those as distances off of a column line, and then you can kind of measure out where that is on the floor. But the real, like I said, the real high-tech way to do this is if you also have a total station on site that can use a laser pointer to directly illuminate a point, you can feed these coordinates back into the total station, have it shoot out that point, and locate it on the floor for where the high spots and low spots are. If you're not doing a survey controlled scanning where your scans are not on a coordinate system that's known out in the field, or if you're doing like a targetless registration between scans, then what you'll do is the origin of those scans is going to be the scan location. Because if the scanner doesn't have any other coordinate system to reference to, the 0, point in scans is where the scanner's sitting. So if you take a measurement on the floor in northing and easting, well, that's how far you are away from the scanner. And then that's where you measure from to get your points laid out.
Yeah. Well, this does bring up, one of the things where I think, at least for me, I was always a big fan back in my VDC days of scanners that could tie into control in the field. That was always like a prerequisite for me, and I think I was a small minority. But I think the value of that functionality is increasing as we get closer and closer to these kind of near real-time workflows, right? Because the data is just so much more usable if it's in the coordinate system that's being used to build the job. So, like scanners can shoot control points with your little paddle targets or spheres. The TopCon GLS 2000, the GTL 1000, which is basically just a total station with a really cool scanner on top, right? That obviously that can tie into any kind of control on site. There's one or two others that can just do it in the field, but I'm not recalling off the top of my head. But
yeah, so I think
go ahead.
I think the ZNF scanner has some capabilities to do that as well, but these are all using kind of checkerboard targets or these black and white targets. If you're using scanners that are for building scanning, like a Faro Focus or like a RTC, you'll typically do that using checkerboards that are out in the field that have been shot with another instrument like a total station. But if you have something like a GLS 2000 that can pick up reflector and reflectorless targets and occupy a known point, or the GTL 1000, which is actually ideal because it's a total station that can do laser scanning, and so you don't need a second instrument to get these things registered.
Yeah, and that definitely speeds up your workflow. The other part of Toby's question though was, if you're doing the processing off-site, like in a separate location, how do you get that information out? And Zoltan showed a couple of the reports that we've got in Rithm. There's a bunch more. There's a lot of different export options, DXF, CSV, et cetera, et cetera. So there's a number of different ways to kind of get the data out of Rithm and get it back into, magnet field, get it back into Trimble Business Center, get it back into, whatever kind of software package that you're going to be using in the field to kind of figure out where you need to do remediation or, make changes. A lot of different ways to get the data out. So, yeah, I think, I think that's everything. So with that, I think we'll call it a day and say thank you everybody for joining us, and thank you for all the awesome questions. Lots of really good ones. please, reach out to us. Shoot us an email. You can see the email address down there. Get a hold of us on our website, hit us up on social media, whatever floats your boat. We would be happy to talk to you. If you have more detailed questions, want to do a kind of a full demo where we can get into a lot more of the little detailed features, always happy to do that. So looking forward to hearing from several of you, particularly looking forward to hearing from you, Carlos. Send me your credit card and we'll get you taken care of. So
he's only half joking.
Yeah, beg your pardon?
I say Kelly's only half joking.
Oh yeah, only half joking. But yeah, anyway, fantastic. Zoltan, thanks for walking us through the demo, and thank you everybody for your hour of attention. Yeah, see you at the next one.